Hey guys, Mr. Backerberg here. In this video, we're going to take a look at the cotangent function. Now, graphing a cotangent function is going to be very similar to graphing a tangent function in the sense that we're going to find asymptotes first. But where those asymptotes are located are a little bit different than our tangent function. So, for example, if we wanted to look at the function f of x equals the cotangent of x, to find the left asymptote, then what we're going to do is take the bx plus c stuff inside of our parentheses, and we're going to set it equal to 0. So if we're just looking at a basic cotangent function, then we're just going to have an asymptote at x equals 0. And then to find our right asymptote, we're going to take that bx plus c stuff inside of our parentheses, and we're going to set it equal to pi. And in this case, we're just going to get x equals pi. So I'm going to say pi is out here somewhere. Then I need some x and y values, and just like we did with our tangent function, we're going to look halfway between our two asymptotes. So halfway between 0 and pi is pi over 2. Now if I plug that in, remember cotangent is x over y. So at pi over 2, we get an answer of 0. Now I want to look halfway on each side of this point and with my asymptotes. So on the left-hand side, between pi over 2 and 0 is going to be pi over 4, and the cotangent of pi over 4 is 1. Then if I look halfway on the right side, between pi over 2 and pi, that'll give me the x value of 3 pi over 4, and the cotangent of 3 pi over 4 is negative 1. And a lot like the tangent graph, I'm going to start in the middle. I'm going to work my way left first, so I have to go through that point pi over 4, 1, and then I'll have to follow my asymptote up. And then if I start in the middle and go to the right, same thing, I got to hit that point, and then I'll follow my asymptote down. So it ends up looking sort of like an upside down cubic graph. We're going to look at another example of graphing out a cotangent function, and we're going to do f of x equals 3 cotangent of x over 2 plus 1. And the first thing I want to find are my asymptotes. So for my left asymptote, I'm going to take the stuff inside of parentheses, set it equal to 0, so I'm going to get x equals 0. So my asymptote is right along this x value of 0. Then for my right asymptote, I'm going to take the stuff inside of the parentheses and set it equal to pi. Now I have to multiply that 2 over to the other side, so I get x equals 2 pi. Now I want to get some x and y values to be able to plot out on my graph. So halfway between 0 and 2 pi is pi. When I plug in that x value, the first thing I have to do is divide it by 2. So pi divided by 2 is pi over 2. The cotangent of pi over 2 is 0. Times 3 is still 0, but then I have to add 1. So at pi, I'm at 1. So halfway in the middle, I'm up at 1. Then halfway between 0 and pi is pi over 2. Pi over 2 plugged in for x, the first thing we got to do is divide that by 2. So pi over 2 divided by 2 is pi over 4. The cotangent of pi over 4 is 1. Times the 3 out in front is 3. Plus 1 is 4. So at pi over 2, we're up at 4. And then I need to look halfway on the right-hand side. So halfway between pi and 2 pi is 3 pi over 2. And I plug that in. 3 pi over 2 divided by 2 is 3 pi over 4. The cotangent of 3 pi over 4 is negative 1. Negative 1 times 3 is negative 3. Plus 1 is negative 2. So at pi over 2, I'm down at negative 2. And then I connect my dots with my line to get that sort of upside down cubic looking graph, following those asymptotes up to the left and down to the right. That's going to be it for this video. Thanks for watching.